Welcome to section 11.1, part 2. This is the 103rd session of the CISSP exam prep series. We pick up the walk down the stack where the last part left off. In this session, we'll work through the lower 6 layers and the gear that lives at each one. We'll answer several questions. What does the presentation layer handle? What does the session layer manage? What does the transport layer guarantee? What does the network layer decide? What does the data link layer stamp on each frame? And what happens at the physical layer? Why does this matter beyond the exam? Because every network control you deploy attaches to one of these layers. Suppose you are hardening a branch office. Your encryption choice, your routing rules, your switch settings, and your cabling all belong to different layers. When you can name the layer a device operates at, you know exactly what it can and cannot see, and where to place the defense. Let's set the scene before the detail. The lower layers each own a specific job on the journey from software to signal. Formatting, dialogue, delivery, routing, framing, and finally raw transmission. On modern networks that run the Internet Protocol suite, a couple of these layers have no separate existence and their work is folded elsewhere. Keep that quirk in mind as we go, because the exam loves to test where those duties actually land. What does the presentation layer handle? It is the translator. It reshapes data into a standard format any compliant system can read, imposing common structure and formatting. It is also where encryption and compression traditionally sit. Here is the catch. On Internet Protocol networks, there is no real presentation layer, because reformatting for transport is rarely needed. Encryption still happens, just in other places, such as before data enters the stack, at the transport layer, inside a VPN, over wireless, or in bulk at the physical layer. What does the session layer manage? It is the conversation coordinator. It opens, maintains, and closes the dialogue between two machines, sets checkpoints so a broken exchange can resume, and decides the direction of flow. That direction comes in 3 modes. Simplex is one-way only. Half-duplex is 2-way, but only one side at a time. Full duplex is 2-way at once. And again, on Internet Protocol networks, there is no distinct session layer. Those duties get handled by the transport protocol, or not at all. What does the transport layer guarantee? It manages the integrity and control of the connection. It establishes a logical link between 2 nodes and defines the rules of the session, how big each segment can be, how integrity is checked, and how lost data is spotted. It handles sequencing, error checking, flow control, and multiplexing. Think of it as a shipping manager who numbers every carton, confirms each arrives, and reorders whatever went missing. Its main occupants are the reliable transport protocol, its lightweight, connectionless cousin, and transport layer security. What does the network layer decide? It handles logical addressing and routing. Logical addressing means an address assigned by software rather than burned into hardware, and the header here carries the source and destination IP addresses. This layer chooses the path but does not promise delivery. The device that rules this layer is the router. A router reads the destination IP address and picks the best path by speed, hop count, and preference, using its routing table. Picture a dispatcher choosing the fastest route for each delivery truck based on live traffic. What does the data link layer stamp on each frame? The physical hardware address. This layer formats the frame for the specific network technology, such as Ethernet, and adds the source and destination MAC addresses. A MAC address is a 48-bit hardware address written in hexadecimal, and its first half identifies the manufacturer through a registered vendor code. Because that code is tied to the maker, some devices can be recognized by their MAC address alone. The gear here is the switch, which forwards each frame out the correct port based on its destination MAC address. What happens at the physical layer? Everything becomes signal. This layer converts a frame into bits for transmission over the medium and turns arriving signals back into bits. There is no logic about meaning here, only electricity, light, or radio. The devices that live here are the humble ones: network cards, hubs, repeaters, and amplifiers. A hub blindly copies a signal out every port, and a repeater simply boosts a signal so it can travel farther down the wire. So let's bring it together. The presentation layer translates, encrypts, and compresses, though the Internet Protocol suite scatters those duties. The session layer runs the dialogue in simplex, half duplex, or full duplex, and likewise has no separate existence there. The transport layer guarantees the connection with sequencing and error control. The network layer routes by logical IP address, ruled by the router. The data link layer stamps hardware MAC addresses on frames, home to the switch. And the physical layer turns frames into raw bits, home to cards, hubs, and repeaters. Map any control to its layer, and you always know what it can protect. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.